Tong Liang, you have been diagnosed with hypertension. So this is your prescriptions. You can bring it to the pharmacist to get your medicine.
Oh my god, what is hypertension? Why I got this disease? And why is this not feel? I don't understand this. You want me to eat? I don't want to eat.
You just eat it. I am a doctor. You should believe me.
Hi, good morning. This is your drug lisinopril. You should take it orally and do not stop without the permission of the doctor.
What is this lisinopril?
Okay, the lisinopril is used to treat your hypertension or congestive heart failure.
How does this work?
Okay, the lisinopril will serve as the ACE inhibitor. Works by relaxing your blood vessel so that your blood can flow easily, which can reduce your blood pressure.
Okay, I'm now quite interested about this medicine. Can you tell me more about this medicine?
Of course you can. Now I will explain about it to you.
The travel name of the drug is lisinopril and the IUPAC name of the drug is 2S1 2X6 amino acid 2,1S1 carboxy 3-phenylpropyl amino hexanoid pyridine 2 carboxylic acid. Okay, let's talk about the chemical structure of lisinopril. So this is the 2D structure of lisinopril. Okay, next, this is the 3D structure of the lisinopril.
Now I will talk about the functional groups of the lisinopril based on the chemical structure of it. So these functional groups are benzene ring, carboxyl, two carboxyl groups, two amide groups, and one amide group.
Okay, now I will explain about the synthesis of lisinopril. Okay, overall got total 6 structures to produce lisinopril. I will start with structure 1 and structure 2 first. Okay, the structure 1 is from L-lysine and the structure 2 is L-purine. Okay, this is benzene group and this is oxygen bonded to tertiary butyl. Okay, the first structure will contribute hydroxyl group, and then the second structure will contribute one hydrogen group to produce one water molecule which has H2O, and with the reaction of dicyclohexyl carbodiamide, triethylamide, and dichloromethane, if the structure 3 will be produced, which is this structure 3. Okay, in structure 3, this group will be removed and replaced with hydrogen group, and this benzene group will be removed also and replaced with one hydrogen group to produce hydroxyl group, and then with the reaction of 10% of palladium on carbon catalyst and ethanol, the fourth structure will be produced, which is here. Okay, in the fourth structure, it will combine with this structure. This structure will contribute the OH group, and then the fourth structure will contribute the hydrogen group, and then this OH and H will combine together to produce H2O, which is water molecule again. Okay, in the fourth structure, it will react with the sodium cyanoborohydride with this, and then through the reverse transcriptase, the fifth product will be produced, with is here. Okay, the final product will be produced through remove from this group and then replaced with hydrogen, and then finally with the production of trifluoroacetic acid, which is here, it will produce the sixth structure, which is lisinopril.
Okay, I am Raza, then I will proceed to explain you all about the stereochemistry of lisinopril. Lisinopril exists as an equilibrium mixture of cis and trans isomer, and there are 23% for cis and 77% for the trans. These isomers are assigned to a cis-trans equilibrium of the rotation around the amide bond, as you can see the structure below. In the normal condition, most peptide bonds adopt the trans-isomeric form. It is because of the weaker steric repulsion between the hydroxyl group and the carboxyl group effect in the molecule when compared to the cis. The trans-isomer in lisinopril is the most preferred isomer and biologically active. As you can see the structure in this slide, it shows generally about the transformation between trans-isomer and cis isomer. Move on to the next slide. In this slide, you can see there are two chemical structures of lisinopril in form of cis isomer and trans isomer. This structure show lisinopril contain chiral carbon. This is because structure of lisinopril molecule does not identical with its mirror image. Based on structure A and B, it shows that lisinopril contains 3 chiral carbon in which tetrahedral atom with 4 different groups attached to it. Because of that, we need to analyze them separately, whether it is R or S isomer. Firstly, we need to assign a priority based on the atomic number, then trace a path from the higher atomic number to lower atomic number. So, based on my observation, it showed that lisinopril showed the anti-clockwise rotation for all chiral carbon presented in that molecule. As a conclusion, lisinopril will biologically active in the form of transformations with S rotation.
Since lisinopril acts by means of inhibiting action, it does not being metabolized. Thereby, no reaction happens on lisinopril structure inside human body. Thus, the reaction can only be seen when lisinopril react with other drugs to produce adverse effect. For example, the combination of lisinopril and aliskiren can cause the risk of low blood pressure, increased blood potassium, and renal impairment. For lisinopril and alprazolam, the combination may have additive effect in lowering blood pressure, which can cause headache, dizziness, and fainting. For lisinopril and losartan can increase toxicity of the other by pharmacodynamic synergism, as dual blockade of renin-angiotensin system increases risk of hypotension, hyperkalemia, and kidney failure. Ibuprofen decreases effects of lisinopril by opposing drug effects. This causes potential for reduced effectiveness in lowering blood pressure. In lisinopril structure, there's carboxylic acid functional group, which can undergo conversion to acyl chloride when react with SOCl2 or PCl5, undergo reduction, undergo conversion to amide, or undergo conversion to ester. For the functional group of amide in lisinopril structure, which are shown in the yellow box, the reaction of amide is hydrolysis, which causes the cleavage of bond to produce two products. For the reaction of amine, there's two types of reaction of amine. Firstly, the primary amine will undergo conversion to amide when react either with carboxylic acid or sulfonic acid. For reaction of secondary amine, it can undergo reaction with nitrous acid to produce N-nitroso compound or N-nitroso lisinopril.
Now I really understand already. Thank you, Mr. Pharmacy.